Hello there, seventh graders. This is Mrs. Oliver for our seventh grade math team. Today we are going to do some more simplifying of algebraic expressions. Okay, so this fits into chapter 5 still and multiple of the lessons. And as we get through the examples that I have, you will see why it's multiple of those examples. Okay. So let's look at where this is coming from. Okay, we have learned to simplify expressions with the distributive property and combining like terms. Okay, here's our distributive property. Here we find our like terms, 3m and 5m, and combine them. Okay, and this is where we're going with it today. If you notice, you have distributive property plus other terms that we need to put together. And the reasoning why you need to do this is because next year in 8th grade and 9th grade, you will need to do complex equations. Okay, so like I said before, 7th grade builds up what you need for later years. Okay, so if you need to, print out your notes that go with today if you are a virtual only student. Otherwise, you should have gotten a paper from your teacher to fill in your simplifying algebraic expressions, and they will glue into your notebook. So let's look here. We have first example that we are going to model. Now, modeling does not mean just solve. It means you are putting down some type of representation, drawing variables, integers, chips of how you would solve this. Okay, so when I look at 5 times the sum of 4 and x minus 2x, this 5 here tells me that means there's 5 sets of this 4 and x. Okay, when I pull this out, I'm actually going to put 5 different sets of my ones with 4 of them because there's a 4 in our part, and then I'm going to put 5 more sets or 4 more sets. So there's 3, 4, and then there's my 5th set. Okay, and you just repeat that. And that's that first section of it. Okay, and then here's for second part. You notice I'm using the same thing because I had 4 plus my x. And we have to use still an x because we don't know what it represents. We don't know its value. So that part right there is just going for our distributive property. Now I need to put the next one down. Remember, if we were to add our opposite, that is a negative 2x. So I need to put 2 of these negatives. Okay? And the reason why I don't have to put 5 of those is because it's not inside the parentheses. It's outside the parentheses. Now we go through and look. Can we cancel anything out? Just like before when we did integers, 1 positive and 1 negative equals 0. So this one can cancel and this one can cancel. So then what am I left with? Okay, well, let's see how many of our x variables we have. We have 1, 2, 3. So that gives me a 3x. Now we look. Oh, you know what? I forgot another row of my ones. Oh, I forgot this row. 2, 3, 4. Okay, I saw I had only 4 rows. I'm like, I need 5 rows. Okay, so now we add them. If I have 4, 8, 12, so that's my 4, 8, 12, 16, 20. I'm now going to add 20 to my expression. And that is my final answer for my first model. Okay, that is it simplified. If you look, there's a lot less terms in it. That's how it's simplified. Okay, now can I just draw this without having to drag and drop? Yes. So you're at home, you're going to have to draw it. Okay, so first I start with 5 x's. Okay, so 1, 2, 3, 4, 5. They're positive. Then I have 21s that I am adding. So I'm going to use some tally marks so that I know that means it's 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So right there's my 21s. Okay. Next, remember this is really a -3 that is being multiplied to both these terms. And that negative in front of the 3 means to do the opposite. So the opposite of having a positive 4x is a negative 4x. And then how many sets of those do I have? Well, I have 3 sets of them. So there I have all of my negative x's. So, and then the next one says I need 3 sets of the opposite of a negative x, or -8. Sorry, my bad. The opposite of a -8, a positive 8. So 1, 2, 3, 4, 5, 6, 7, 8. I gotta do that 3 more times. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And let's go through. Is there anything I can cancel? Okay, I have some positive x's, I have some negative x's. So if I have 1, that one's gone. 1, that one's gone. That one's gone. There's 4, and then 5. Now all my 1s are actually positive. So I can't cancel any of my 1s. So I need to add up how many actual x's do I have. There are 1, 2, 3, 4, 5, 6, 7. Okay, so I know this is a -7x plus, we got to add up all our 10s. And this is why if you did with tally marks, it makes it easy because now you can skip count. 5, 10, 15, 20, 25, 30, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44. And then that is our final answer. Look how much smaller that looks than the expression before it. That's why it's called simplifying. You are making it into its smallest form. Okay, if you need to, pause this and catch up, fill in your notes. Now we're going to do this the arithmetic way, okay, instead of modeling. So the first thing I need to do when I do this is I need to actually take my 4 out here and distribute it. And I always rewrite my problem. Okay, so I know I got to take 4 times y plus 4 times 2. So I'm going to bring down what this is originally. So I have 8y minus my 4y plus another 4y plus my 8. So let's look, what can we combine together? I have all these yo-yos to sort out, okay? If you notice, we have an opposites, a -4y plus a positive 4y. Okay, if I had 4 yo-yos and someone took 4, that means I have none there. So I'm only left with that 8y. Right? And then we have our lonely constant of +8 that just stays as it is. So our final answer is 8y plus 8. Okay, so now if we need to pause it, catch up, we're going to go to the next example. Okay, You need to think of it as adding your opposite, but that's a -4. We are taking this -4 times everything inside the parentheses. And it means to do the opposite of what we have. Okay, so I know I have a -4 times a 6x plus a -4 times 2. So I'm going to rewrite it using that 9x that is not inside the parentheses. Okay, and since I know this is a -24, I'm just going to write it as a subtraction problem. And I'm going to write this as subtracting 8. Then we just look for what are our common numbers, our like terms. Okay, x's go with x's. So if I have 9 x's and someone needs to take 24 away, I'm going to be short 15 x's to give them. And then we have our lonely constant of -8. So our final answer is -15x minus 8. And we need to pause it. We only got a few more examples to go. Okay, so for this one, I'm going to take my 10 times 8x, my 10 times 5. You notice I always write this down just so I know I'm not making any silly errors. So I'm making sure I'm distributing that 10 to both terms inside the parentheses. Okay, so that's an 80x minus 50. And then remember, we have to bring this part down too. Plus 5x minus 6. Now we can go look. What are some like terms we have? I have 80x and 5x. And then we have -50 and -6. Okay, so if I have 80 pencils and someone gives me 5 more pencils, that means I have 85 pencils. Okay, we can't get rid of that variable. We still don't know what it means, what its value is. Okay, so then next I have my -50 minus 6. Well, that adds your opposite. Same signs, add and keep. So it's a -56. And that is our final simplified expression. Okay, let's look at our next one. All I see is a negative. Oh no, what is this little negative mean? Well, it means there's a -1. It's that invisible one that likes to just hang out and disappear on us. That also means to do the opposite of everything that's inside our parentheses. So what's the opposite of a 2x? A -2x. What's the opposite of adding 5? Subtracting 5. And then we still need to bring down the rest of our expression. Now we can go through and look for those like terms. X's go with X's. Okay? If I owe you 2 X's and I got 12, I really only have 10 X's. And I keep our lonely subtraction of 5. 10x minus 5 is our final answer. All right, let's look at our last two for our notes, and then we'll talk about some of the homework. All right, I have distributive property of 2 times 3x and 2 times 4. Okay, so I have an 8x plus 6 plus a 6x plus 8. Okay, go ahead, combine your like terms. I have a 14x plus 6 plus 8 is 14. Right? I challenge you to pause and try to do the next one on your own. Okay. right, once I was done, I had a lonely 12x left. If I had 6 yo-yos and someone took my 6 yo-yos, I have no yo-yos. Okay, so your homework today, you're going to start with the back sheet. It's more like what we did with our notes today. Tomorrow, you'll go to the more complex side and do the front. Okay, so today, let's look at 11 and 12. Now remember, this is a -4. That means do the opposite of what's inside your parentheses. If I have a -4 times 5b plus a -4 times 4, and then remember to bring your tail end of 10b back down. All right, so this is a -20b plus a -16 minus 10b. All right. If someone stole 20 bananas and then stole 10 more bananas, how many bananas have they stolen? That means I am short 30 bananas. All right. These are what I combined. This is what's left. Since it's addition of a negative number, I'm going to rewrite it just as a subtraction. I'm going to undo the adding of the opposite. All right. If you're still watching this, put a star at 12. Right? I have to take 4 times 9k. Like saying you have 4 cages with 9 kangaroos in them. And then my 4 times 1. So don't forget your -4k. Okay, so that means I have 36 kangaroos plus 4, but then 4 kangaroos ran away. If I started with 36 and 4 ran away, I only got 32 kangaroos left. And then we keep our lonely little 4. All right, that is how the rest of your homework should end up. Okay, so make sure you're going through slowly, double checking everything that you can.